I think one of the questions I get asked the most is the question of sample size. How large does my sample need to be? How small can it be? How do I work myself up in order to get it right? And that's a question that cannot be generalized. Some scientific disciplines try to solve it. There are clever ways such as power analysis and all sorts of approaches where people say we know exactly how large our sample needs to be. And that might be the case for their specific experiments and circumstances. But what comes to pass here is one more time the law of Occam's razor. So your sample size needs to be as big as possible and as small as necessary, I want to say. So if it would be incredibly large, it doesn't work, right? You can't sample it. Then you wouldn't have a sample that really represents the whole world. It would literally be the whole world. So that's too much. Then if we come into the whole question of bias and how something is not well represented and so on, it's too small. So you need to catch the diversity that you have. Well, and this is where then probability comes to pass, because probability tells you that the phenomena that you sampled and the pattern that you observed and the results that you get, they are somewhat, well, there's a high chance that this will not change, that this will be solid over time, no matter what you add. If you made a mistake, if the world changes, well, our knowledge changes. This is what knowledge does, it changes. But what's more important than to remember is that at the moment in time, when you started the sampling, when you designed your study, when you did the whole thing, you did everything to the best of your knowledge. And what we then need to acknowledge is that knowledge changes. That's very important to remember. But wisdom then, when it comes to sample size, is really to take the sample that is representative and still feasible to take. So, and also knowing about the limitations, not only of your design, of your study, of your analysis and interpretation, but of empirical studies as such. They are always imperfect. We always approximate knowledge. You can't say I made a perfect model of the world. It contains any entities and is equal in all mechanisms and heuristics that I observed. It's not a model, that's a facsimile, and that won't work for you. So what you need to remember is you need to learn. You need to practice about your sample size. And you need to get experience on how you do that. But what you can maybe as a simple heuristic remember for yourself, what would one more sample do? What would 10 more, say, interviews in an interview campaign do? Or what in a scientific experiment focusing on plants, what would another 100 plant pots do? What knowledge would they add? How does this change not only the diversity and the precision of your knowledge, but most importantly, the probability that if you infer this change, does it make your knowledge better? Does it make it more permanent? Because we want knowledge that is as permanent as possible, and then it changes.